Hi everyone, I've been meaning to do one of these tutorials for a number of years and I have repeatedly failed to do that, but here we go. This is the first time that I've done one of these. So what I'm going to talk you through is the process involved for creating maps and landscapes from GIS data, mainly digital terrain models and LiDAR data. So the first thing that you will need is some LiDAR data or some elevation data. And you can get that from a number of sources, but there's some really good open data available from local governments, such as this portal here from the Scottish Government. And what you'll get when you download that data is tiles of DTM or DSM data. So when you import that data into GIS, the software interprets the elevation as an image, a grayscale image where black are the lowest parts and white are the highest, and then a sort of stretched gradient in between. But the issue is with Blender is that when you import that data, it doesn't necessarily deal with the no data values very well. So there are quite often a number of steps involved in GIS in terms of processing that data, which I'm going to take you through. So you might want to stitch various tiles and mosaic them together, or you might want to resample that data if you have a very large data set to make it smaller, or even reproject it. So if we switch over to Blender, the first thing you need to do is if you press A to select all the objects and delete, and then we get rid of those default objects, and then we need to enable an add-on. So in Edit, Preferences, if you search for Image, we want the Import Images as Planes option. And what that allows us to do is go to File, Import, Images as Planes, and then if we choose one of those LiDAR tiles and import it, what it does is it maps that image onto a plane, and we can see that by switching render engine to cycles and then viewport shading in the top right corner to rendered. And what you might notice is this is the same data we were looking at previously, is that Blender doesn't properly interpret that no data value, so that the lowest part is very low in terms of values and the highest part is white, and there's hardly any sort of gradient of grey in between. And if we inspect that data in FME, you can actually see, clicking on the values, that the no data values are minus 9,999. So when that image is stretched across the whole data range, Blender doesn't properly interpret those values. So, not to fear, we can do something about that, and there are a number of ways of stretching those values across the entire image. So even this one here the image looks to completely fill the height values. There is some very small holes which are filled with no data. So in ArcGIS you can export a different version, so a different raster format. So typically what we might want to do is use say a 16-bit TIFF or PNG, and if you choose this option here, scale pixel value, what that would do is properly scale all of those real elevation values across the entire range of the image. However, if you're lucky enough to have FME, there's also a tool, a transformer called the raster interpretation coercer, which will do that job for you. So here we're reading in a GeoTIFF DTM, and the raster interpretation coercer is set to a 16-bit grayscale image, which will still provide you with a very detailed high resolution image, but it will drop the bit depth down to 16 bits rather than 32 bits, and it will do that job of scaling those data values across the entire image. Okay, so now what we can do in Blender is delete that one there and then import our properly scaled DTM grayscale image. So I have made one here called Arran DTM. So this is on the Isle of Arran in Scotland, and it's a really nice 1 meter resolution data set. So now if I import that image, we should be able to see the difference that scaling has made. So it's a little bit gloomy, so we will add a sun lamp. And if you go into the light bulb here, click use nodes, you can increase the strength of that sun lamp. So this is that same DTM tile that we're looking at here, but those values have been nicely stretched across the entire image. So in terms of making landscapes and terrain models in Blender, there are a few different approaches. There's one to do with making a mesh or a surface. There is one to do with displacement, and there is one to do with micro displacement or adaptive subdivision. I'm going to show you a few of those displacement options, then maybe another time I'll show you the sort of surface or mesh-based approach. So the first method I'm going to show you is called the adaptive subdivision method, also known as micro displacement. And this is quite a clever function of Blender in as much as that it will displace your geometry and give you as many faces in that mesh as you have pixels in your texture. So it's capable of producing very detailed and high resolution meshes, in this case terrain models. But it does have some limitations in as much as that it's only found within the experimental feature set within Blender, so it's not fully supported and integrated into all of Blender's functions. But I'll show you both approaches. So if you change that feature set to experimental in the scene settings, then the next thing to do, select your plane and add in the modifiers a subdivision surface modifier, choosing the adaptive function. And where it means it's adaptive is that it will dynamically produce a displacement, but it also does some clever things, like the portions of the mesh that are closest to the camera will get subdivided more, so give you more detailed, and those further away will give you less. The next thing to do is open up the shader editor, and you need to add in a diffuse shader, connecting up the color output from your DTM into the color input of the shader. And then we need, under vector group, a displacement node. Again, take your DTM, but this time connect it up to the height input of your displacement. Now you can see that it starts to give you a bit of a hillshade view, but no actual displacement, so it's still very flat. To make this work, go into the materials settings and change the displacement type from bump to displacement. And so you can see it's completely changed the geometry based upon the DTM. Now this is obviously massively exaggerated. So if you go into the displacement node settings and change the scale to something a lot less, like 0.05, then this will give us a bit more of a realistic terrain. A couple of other things to change. In the subdivision settings, change the preview rate from 8 to 1. That will give us a preview of that render at a much more detailed level. So it's starting to look a bit more interesting, but you can see this is still really quite flat, and that's because of the sun is pointing straight down, so not really casting any shadows. To change that, go into the transform properties of the sun and give the y-axis on the sun some rotation. You can see as we start to do that, it starts to cast a lot more interesting shadows. Next, in the sun lamp settings, you can play with the angle setting. So if it's 0, you get some very hard, crisp shadows. And if you increase that, you start to get some slightly softer and nicer looking shadows. Next, select your plane and in the shader editor add in under the converters a color ramp. And here we can change the color of our DTM from grayscale to something a bit more interesting. If you change the interpolation to B-spline, this will give you a much smoother gradient as well. Now I find it works best if you use some fairly subtle pastel-y type colors, and you can go mad with this and choose any particular gradient that you want. Generally, the subtler the gradient and the colors, the better it works. So this is okay, and it works well, but it does have some limitations. So I'm going to show you a different approach. This next method is just using the regular displacement functions in Blender. So go ahead and change the feature set back to supported, and we can then delete our displacement node. So this method requires a manual subdivision of our object. So to switch to edit mode, and then in the edge menu, choose subdivide. And if you do Shift R, that will repeat the last function in Blender. So keep subdividing that mesh until we get a very regular grid of faces, as detailed as you like, or as detailed as your PC can handle. So now come out of edit mode, and we want to add a displace modifier. And we can get rid of the subdivision modifier for now. Next, you want to choose a new texture to use. Then in the Textures tab down the bottom, it shows you this is the displacement texture. You want to choose your DTM to use as the basis of that texture. Now again, this is producing a very exaggerated terrain, and it's also got the wrong mapping of that texture. So in the modifier settings, change the texture coordinates to UV. So these UV coordinates were created when the import with planes tool added that plane to your texture. And we can change the strength again back down to something a bit more reasonable. So now we have some less detailed geometry, but much lighter and easier to work with. One of the drawbacks of the adaptive subdivision is that it's a very heavy process in terms of your CPU. And I find that you can achieve the same overall result and have a much lighter model by using this regular displacement method. So now, if you're happy with the levels of subdivision, which looks fine to me, we can apply it. And now, if you go into edit mode, you can see the actual geometry has been changed. So it's no longer a flat plane. But it's a bit bumpy, so we can go and change the object settings to shade smooth. And to smooth it out further, we can add another subdivision surface modifier. But you might be thinking, this doesn't look quite as good as it did before. It still has the same geometry, but to add the detail, we can cheat. And if you choose in the vector group a bump map, we can artificially add the detail back in using the normal mapping function. So not connecting up the displacement, but choosing to use an artificial bump, so a texture to give an appearance of detail. If you dial down the strength, you can get something that looks just as good, in my opinion. One of the things I've been asked quite a lot is how to get different layers of GIS data into your scene so that they are mapped and positioned correctly. There's a couple of ways of doing this. You can import things like FBX or OBJ files with 3D features in them, or you could import 2D features and drape them onto the surface. But the positioning of those is quite a tricky thing unless you've compiled them separately in another program. One of the methods that I like to use, which I'm going to show you now, is to use textures to layer up different masks made from very simple maps created in GIS. So for example, in GIS here I have some features from OS Open Data, from OS Zoom stack, of the water, so the surface water, lakes and rivers. So you could create a very simple map just with a black outline and a white background in GIS and export that to an image. Or as part of my same FME workspace, I'm going and taking my raster data, swapping its geometry with a bounding box, and then using that to go and fetch those OS features using a feature reader. Now the secret to making the positioning of the textures work is to clip your images, so your layers of maps, to the exact same proportions and size as your source DTM. And here in FME, I'm just simply doing that with a clipper. And what you end up with is a very simple texture, which is essentially a mask for the water. And so you can produce various different ones for different layers. So this is woodland, for example. So back in Blender, you can apply those by adding those textures into your shader. So choose Image Texture, and then open Water, and then using a shader called a Mix shader, you can use the water mask as the factor to mix different shaders together. So now if I add in a glossy shader to give the appearance of reflection on water, you can see as I rotate the model, it now has that texture mapped onto it, which is controlling how those different materials are mixed together. So you can go ahead and add as many different textures and mix as many different shaders together as you like. So it's also possible to mix textures and colors of textures as well as mixing shaders. So if I add in another texture now, and one for the woodland mask that I'd made, you can take the DTM gradient and in the color group add a mix RGB node. Again, using the woodland as the factor to mix those two things together, I now have woodland features mapped. And what's quite nice is that you can mix these in many different ways using the blending modes. So similar to things you'd find in Photoshop, where you could say darken or multiply or add colors rather than just mix them together. It's also possible to mix the colors that affect the bump map, so to mix in different shades of gray into your DTM. So I'll show you what that looks like now. So again, add a color, mix RGB node, and here if we add in the woodland, into the factor again, you can see that that's giving it a very sort of subtle drop shadow to that woodland feature. Now obviously that looks a bit strange, but if you were to go and play around with this mix node and actually mix those colors together, you can adjust the factor to get a very hard edge or a very subtle feature on that woodland. So we're starting to build up some layers and it's looking nice. So that's about the end of this tutorial. I hope you've enjoyed it. Hopefully I will follow up with some more on rendering and adding different layers such as particle systems and trees and that sort of thing. Thanks very much.